Right then. Should be all right. I'm just checking it's still working again. Yeah. So, okay. Next bit. Question 4. Not really comfortable with these, if I'm honest. Don't like it. Don't like the notation, but it's that's the difference between engineering and maths, I suppose. But we'll get right into it. So, question 1. We've got 2 times together, and as far as I'm aware, you just times the numbers at the front and you add the degrees, and so it's effectively, you know, this times this. But we're just going to all the times is different ones, so that ends up 3. You'll have a calculator to do that, and then you add the other ones, and we get minus 21 degrees. I had to look at the answers and work that out personally because I've not seen this notation before. But when it gets to the next one, as you would expect, when you divide, you're going to divide those front numbers, but also the logic flips for the angles as well. So instead of adding them, you're going to subtract them. And so we've got 6 and 15 degrees over 0.5 and minus 36 degrees. And that, again, so we're doing 6 divided by 0.5. So that's going to give us 12. And then our angle, again, the logic flips. So it's going to be 15 minus 36, which will make it positive. So we should get 51 degrees. And that should be that. 3 is just a combination of the two above. So if you can do question 1 and 2, you should be able to do question 3. You just have to do the denominator first before you go into the division. So Z2 times Z3. Okay, so it's the same as question 1, this, except obviously the numbers are different. So we've got 0.5 times 3, so that's 1.5. And then we're adding minus 36 and 115. So that is 79 degrees. I'll just double check that. Yeah. But because we're adding 115 and a negative 36 together. So then once you've got that, then you can go for the division after that. So we've got Z1. Z1 was the 6 and the 15. And then we've got 1.5 and 79. So we divide these numbers, we get 4, and then that one subtracting. So we've got 74 minus 64. And I'll just double check that my thought process is correct. Yep, got all those right. So, if you can do question 1 and 2, you can do question 3. It's just extra steps. It's 4 marks where these two added together would be 4 as well. So, yeah, sound. Drawing an Argand diagram, that is just effectively writing your number in XY coordinates as such. So, if we go for the first one, 5AI, we have imaginary numbers or J numbers or however you want to call them. We have them in the form X plus YI. And so we've got the numbers here are minus 6, minus 3, it's J for you guys. So J. And so all that means is the number in front of the J is the Y coordinate and the other number is the X coordinate. So in this case, we'll go into minus 6 and minus 3. And we just draw a point here and then we draw our line from there. So converting it into polar form it's really helpful to have the diagram, and that's why it's there first. And we're going to take this angle here, And to speed it up, really, this is 180 degrees, this straight line here. So you got 90 and 90 here. So you just have to work out this angle. And you can do that by using the tangent function. So you've got, that's a height of 3, not 6. 3, and this is a length of 6. So you can use your SOHCAHTOA at that point. So we're using TOA, and that is tan of the angle, whatever the angle theta is equal to 3/6. And you know what? I haven't got a calculator, so that's embarrassing. But we'll carry on 0.5. And I believe, hold on. Inverse of it's in radians. Hold on. (26.6) roughly. You'll know better than me what your lecturer wants to do in terms of decimal places, but 26.6 is what I would do. And then effectively you've got your angle from there is your 90 plus 90 plus 26.6, so that's 206.6. And the number at the front here is the hypotenuse here. Hypotenuse, and that comes from Pythagoras' theorem. So we just square the numbers. So we've got 3 or minus 3. You know, we're dealing with the same triangle either way. So minus 3 squared plus minus 6 squared, all square rooted. And we've got 9 plus 36 square root of 45. So 6.7. 6.71, we'll call it. I have a feeling that angle might not be correct. Minus 153.43. Now that's minus 153 from this side. So, you know, ask the question next time you get the chance, because I've went that way around and it's positive 206.6, and the other way around to make 360. So that the official answer in the book is just 360 minus that 153.3, etc. So I would ask the question on that: would they prefer plus or minus, or does it matter at all? These two added together will make 360. Okay, so that's the polar form part. Thankfully, it's easier going the other way. So you are going to draw your Argon diagram again. What's the number this time? 4 and 25. So all we're going to do is we're going to just draw an angle of 25 degrees, not to scale, and then a 4 here. Now there's a good point actually. You might have to draw it to scale, so protractors and things like that. I'm not sure on the context of the exam. And then from there, we are finding these points and these points across. Just go in the opposite direction. So that's your 1 mark for drawing it. 25 degrees and a 4 there, and then convert it into Cartesian form, which is this is the Cartesian form here. So we need some J's in there. So for the x, if you want to memorize it, x is just cos 4 cos 25. So like the number r, the hypotenuse, cos the angle, and that should get us 3.63, and then y is then 4 sine 25. It's 1.69. So then when you get that, you then put that into your i's and your j's, or just your j number in this case. So you get 3.63 plus 1.69 j. Now I'm doing this on Google's calculator, so it might come up with surds and things as such. No, it doesn't. So if it came up with surds or something, you could just leave them as surds, but it's all right. And that's just square roots and things like that. Yeah, that's that done. So I'll move on. 60A, nice one, really. Scalar and vector quantities. So basically vectors or anything that has a direction. So an example would be a scalar would be speed, and then this one would be velocity. So the speed and velocity matter because like Usain Bolt fastest man alive, but it definitely depends on which direction he runs. If he doesn't run towards the finish line, he doesn't win. So that's the type of idea. Typical ones are scalars, time. I believe mass is volume, and then we've got instead of mass, if we wanted to make it a vector, we've got weight. And we've got all sorts of forces, different forces. And that leads on to this part, I suppose. So there's two different ways you can do this. I would usually teach quite a long, convoluted way, but the examiner has been teaching you how to add and subtract things like this. So I'm wondering if we go down the same route. I'm gonna try it. I'm gonna try it one way. It might not work though. So this is like minus 90 degrees, and this is 45. So all the way across here is 135. So I'm going to try it the way the question paper is written, but it's not the way I would do it. And if I don't get the right answer, then I'll just revert back. So A, B, C, that's nice and easy. So resultant forces are just all the forces added together, and then the force at the end is the result. So the resultant force. So we're just going to do A plus B plus C, and that is 9, and the angle is 135 degrees plus 5, and the angle is 20 degrees, and then finally we've got 7, and it's minus 90 degrees. Okay, so then just adding all these together, we've got 21, and adding all the angles together, this doesn't look right though. 155 minus 90, so 65 degrees. Doesn't look right. We'll see. Definitely doesn't look right. Yeah, I didn't think so. Okay, so there's a way to do it, but it's much longer. So what we've got to do is we've got to do what we've just done previously and get in the different components. So what we want to do is we want to have these arrows in their x's and y's, and then we can add all the x's together, get an x, and we can add all the y's together and get a y. So again, I said it's x cos the angle to get it down here. So we're going to do 5 cos 20, and we get 4.69 I'm going to call that 4.7. So 4.7, and then the y is then 5 sine 20. So that's 1.71. And we're going to do a now. So this is 9 cos 45 is 6.36, but it's a negative. And 9 sine 45, and that should be the same number, 6.36. So 6.36, but that is positive because it's going up in the x, right? So we've now actually got them all. We don't need to do much with this one. This is just -7 in the y. So what we do from there is we get our x's together. So x would be 4.7 plus minus 6.36. There's no other x's there. And what's that going to give us? Minus 1.66. And then our y is 1.71 plus 6.36 minus 7 gives us 1.07. And then from there, we just say it's calculate the resultant force. So I'm actually going to draw another diagram. So then we have a y of 1.07 and we have a minus 1.66. And this is our resultant force going that way. That's how I knew it was kind of wrong when it said 21. So to get the actual value of the force, so we'll call this force D, we're going to take our Pythagoras again. So these two numbers, so x squared plus y squared, these two here, and square root them. So we've got 1.66. So we get 1.97. And then we just need the angle from there. So that is, again, the inverse of tan to the minus 1 of 1.07. Oops, over, yeah. And the positive doesn't matter, so we'll do that. And that is 32.8 degrees. Okay, so looking at the answers, I should be closer this time. So 1.98 and 147.2. And yeah, so I may have rounded wrong here for the 1.97, so I know that's okay. But the 32.8 is actually this bit here. So what we need to do is to get this angle and just subtract that from 180. And that'll get us the answer we need, which was 147. That's 147.2. There you go. Okay, so that's that done. Yeah, all done. And we're getting on to other stuff now. So, IJs and Ks. Hopefully this is fairly straightforward, but you can just put the 3 in front of the value of A's. So 3 times all of this. And then just times them all together. So you've got 12i plus 6j plus 9k. Next one, just adding them together. So it's literally writing it all out. So 4i plus 2j plus 3k plus 3i plus k plus 5i minus 3j and plus 2k. And then you can only add the i's together, you can only add the j's together, and you can only add the k's together. So we've got 4i, 3i, 5i, so that is 12i plus, sorry, minus j, and then 4k, 6k, plus 6k. And that's that there. And then subtracting's similar. I'll not go through that, but just be careful if you are subtracting and there's already a negative in it. Subtracting a negative makes a positive. And you've got the answer for that one. Okay, probably a good time to pause. However, the differentiation and integration is quite extensive, and so what I'm going to say is question 8 and question 11 are all skill based. So I would focus on 8 and 11 in terms of differentiation and integration before you focus on the rest, because this is like application based. So you can't do question 9 if you can't do question 8, and you can't do question 10 if you can't do question 8. And for 11, you can't do these two if you can't do 11. So it's really important that you focus on the skills that are in 11 and 8. That's all I want to say to start off with. Okay, so just a quick run through differentiation. So if we've got a polynomial such as this, need to make sure I cover all bases. What we do is, when we're differentiating, we're timesing the coefficient, the 3 or the 4 or the 1 in this case. We're timesing that by the front number and then taking 1 off. So it's denoted like this. This is differentiation, dy dx. And so for that first term, we're timesing the 6 by the 3 and getting 18. So 6 by 3, 18. And then what we do is we subtract 1 from the power. So 18 squared. Okay. So it's the same for every term. You look at the power, times it by the front number, the coefficient, and then subtract 1 from the power. So have a look at the next one, see what you think it might be. And then I'll tell you, we are bringing that 4 down and making it 8, but that negative stays there. Okay, and then we subtract 1 from the power, so 8x cubed. These two are really important cases, a little bit different to what you would expect. So we're timesing by 1, so making it 6. But then when we subtract 1 from the power, we get x to the power 0, which isn't worth writing, so we just write 6. So if like 7x goes to 7, minus 5x goes to minus 5. Okay, so etc, etc. Okay, so the x just gets omitted on that one. And any numbers, constants 9, 115, 25, minus 60, or even like pi, it just go to 0. So the 9 just disappears. That just goes when you differentiate. Okay, so that's just an example. And so... again, I'll try and find worksheets with answers so you can basically do a shitload of practice on those. For question 1, we just need to get it so it looks a little bit like this. So we're going to expand these brackets first. So y equals x plus 1 squared, which actually means just x plus 1 bracket, x plus 1 bracket. And so expanding those out, I'll not go through the long-winded way, but you should know how to expand it, and you get x squared plus 2x plus 1 is your final answer, and then we differentiate that. So the 2 comes down. There's no number there, but actually it's a 1. So 2 comes down, so 2x to the power of 1 plus 2, and again the 1 goes to 0. Okay, so that's your first answer. This one's nice, it's already done for us, so we can just go straight ahead and differentiate that. So 3x squared plus 6x minus 3. And again, we just times those numbers. So 3 times 2 is 6, minus 1 off, so 6 to the power 1. 6x, like this one, goes to just 6, and the minus 3 goes. And that's your final answer. The third question is a little bit different because our x is on the bottom of a fraction now. So we've got 4 over x cubed. Just double check, yeah. And so what we need to do is we need to make it look like question 1 and question 2. So we need to bring that power, like, or that x up. So the way we do that is we rewrite it with a negative power. So we've got 4 minus 4x to the power of 3. And then we differentiate from there. Okay, so the 4 disappears, just like the minus 3 does, just like the 1 does, or the 9. So the 4 disappears, and then we're left with minus 4 times minus 3, which is positive 12. And then we subtract 1 from the power, so that goes to minus 4. Temptation is to go to minus 2 there, but we're still going down. So the more negative we get. And that's that one done. Yeah, question 4. I'll just get that copied. So 4 then x minus x. Okay, so I suppose it's a really simple rule in this one where you just remember that ln x goes to 1 over x. So when you differentiate ln x, it goes to 1 over x. So here we get 4 times 1 over x, and then this one goes to 1. So it's effectively 1 to the power 1. So 1 times 1 is 1. Subtract 1 off the power, gets rid of the x. So that's what we end up with. And just to simplify it a little bit more, we got 4 over x minus 1, like that. Okay, the next one, number 5 in 6, is something called the chain rule. So I would perhaps at this stage pause the video and maybe try and find another video somewhere else on the chain rule in differentiation. Because the it compared to the other 4 questions, it's quite advanced, so it's worth watching a whole video on it to get your head around it. So I'll go through it and I'll assume that you have watched a video on chain rule, but I'll also explain it in this one. So we've got y equals a half sine y equals a half sine 2/3 of x. So this is effectively in brackets there, so it can't be touched in that sense. And minus e to the minus x, right? So the chain rule basically works in a way where we differentiate as normal and then we differentiate the inside. So first things first, I suppose we're supposed to talk about differentiating trig. So when we're differentiating trigonometry, it goes in this order. So it goes sine x, you differentiate and you get cos x. Differentiate again and you get minus sine x. Differentiate again and you get minus cos x. And then what happens if you differentiate again? You go to the top. So it's like a big cycle. So if you memorize that, you know part of the way there. And so when we go to this and differentiate in this, we're going to change it to a cos 2/3 x. right? So it's completely different to the other stuff we've just done, right? But the chain rule means then you differentiate the inside of that bracket. So what's the differential? Like in question 1, 2, 3, and 4, what if that was a question? What would that differentiate to? And the answer is 2/3 because it's like x to the power 1. So times 2/3. So you differentiate it as normal, so sine to cos, and then you times it by the differential inside the bracket. Again, you might need another video for that. And then the e to the x, you just bring whatever number it is down. So these are both -1. So we've got -1 times -1. So we end up with e to the plus e. And then you don't do anything to the power, you leave it as like -1x. So you don't do anything to the power for e's, but you bring the number down like you would normally. Okay, and so we just need to simplify that a little bit to make sure we get a final mark. So, on your calculator, half times 2/3. So you get 2/6, which will simplify again. And e to the minus x. So instead of writing another line, I'm just going to get rid of that fraction and make it 1/3 to make sure I get all the marks. There you go. 6, that is, again, chain rule using rules that we've looked at before. So that ln x in question 4 and the trigonometry rules here. So I just need to write it out and go through, but it's nothing I haven't already covered now. Sine 2x, 3 cos x. And then it's plus or minus plus ln x, right? So yeah, it quite nice these actually, given how many pluses there are. Often those are negatives get thrown in. Yeah, so same principle. So we're going to look at our trig differentiation. So we're on sine, so we're going to go to cos. So cos 2x. But because of the chain rule, we're going to times by the differential inside the brackets. And that's going to be 2. This one, the 3's in front, that stays in front, but cos is going to go to minus sine, and that's x. X doesn't matter if it's just x, and ln x we've described already, just something to memorize, goes to 1/x. So then we're into simplifying. So we've got 2 cos 2x minus 3 sine x plus 1/x. And that is the skill-based differentiation done. And that's a load of marks. So if you can do that, you can, if pass marks 50%, you can almost forget about the other 2 differentiation questions. Yeah, I'm gonna leave it at that, I think. So then at this stage, right, so I've just went through the differentiation and I'm not going to go through any more. I'm going to get to the integration. I'm going to call it there. But with these, you differentiate with the skills you've just learned in 8, and then you just substitute x in. So you'll get an answer, and then you'll just put 3 in. And then this one, you'll get an answer, and then you just put pi over 2 in. Just make sure your calculator's in radians for that one. And that's it. This one, question 10, find the coordinates of the turning point. So what you're doing there is you're differentiating, you're getting your answer to this differentiated, and it's equal to 0, right? So turning point. So a turning point is just, where the graph turns and the gradient is equal to 0, basically. Like at the bottom of a valley or top of a hill, there's a point at the top where you're no longer on a gradient, you're not on a slant. So we're just trying to find those. So you do y dx, you get all your differentiated points out, and then you make it equal to 0 and solve that, right? So if you solve that and you get an x and a y coordinate for those, and then to determine the nature, differentiate this again, the second differential. Okay, so look at these are sometimes called stationary points. So you might want a video on stationary points as well. And just go on stationary points and find the nature of the point. What you can do is you can then get your x and y in, put it into your second differential, and if it's positive, it is what we call a minimum. And this is a minimum here, you know, at the bottom of a valley or something like that. And then if it's negative, it's a maximum. Now, I would have liked to go through both of those questions, but with time and it not being long until the exam, I thought I'd just skip those and crack on. So I'll get on to the integration now, and I'll do a little overview of the last two questions, but then I'll call it there. So again, lots of skills involved in here. Integration is the reverse of differentiation. So in our example, let's say we've got y equals 6x to the power 2 plus 4x minus 7. What we're doing is we're adding to the power, then dividing. So instead of times and then subtracting, we're adding and then dividing. So just remember in that order. So integrating that, we get we add a power on, so that goes to 6x3, but then we divide. So 6 divided by 3 is 2, and then x cubed. So we've added 1 and then divided the 6 by 3. Here we've got 4x to the power 1, so add 1 and then divide, so we get 2x to the power 2. Here, this is effectively x to the power 0, because it's not there, it doesn't exist. So we're going to add 1 and then divide by 1, so we end up with minus 7x. So whenever a number is on its own, like 6 or minus 7 or 154, you just put an x on it. That's what you do in integration. So yeah, I'll try and rattle through these now. Integrating x squared plus 3, I think I saw. Yep. So just adding to the power, so we get x cubed, but then we're dividing by 3, so just put 1/3 in front. And then again, any number, you just add an x on the end, and that's because it's x to the power 1. You go into x to the power 1. And what your examiner probably wants to see is a plus c at the end. I won't go through that, but it's just like the intercept on a graph. So just add plus c on the end to all of these answers to get an extra mark, I presume. B, what we're doing is it's the same thing as A, but you're going to expand. So we've got the integral of, I'm going to expand it quickly here. So 3x cubed minus 2x squared plus 9x and minus 6. And then you integrate those. So add 1 to the power. It's for the 3, so add 1 to the power, and then you divide by the 4. You add 1 to the power and divide by the 3, so 2/3 x cubed plus 9 over 2 x squared, and then minus 6x. Of course, add the plus c as well. Okay, so it's just adding those powers and then dividing. C, that's where it's starting to get a little bit different. So we need it to look like A and B. So we're going to change these square roots to powers. So we end up with 2 to x to the power of a half, but because it's also on the bottom of a fraction, it's minus a half. Half is just the power for a square root, and then you got 4 x to the half, like that. Okay, and we're just adding and dividing again. So we're going to add 1 to the power for the first one. That's going to take a minus a half to a half. So we've got 2x to the power of a half. But then dividing by a half, 2 divided by a half is going to be 4. And then we do the same on the next one. So adding 1 to a half is going to make it 1.5 or 3 over 2. And then divide by that again, you can use your calculator. So we get 8 over 3 x to the 3 over 2. And then plus c. Okay, always adding plus c unless told otherwise. Integration of trig is just the opposite. The opposite here. So if we're integrating sine, we're going to go to minus cos, and etc. So it's important you've memorized that cycle. Okay. Sine 3x to cos x. And then integrating the sine, like I said, it's going to minus cos 3x, but it is the chain rule again. So the chain rule in differentiation was you differentiate it normally and then times by the number in the bracket. Well, here we're integrating normally and dividing by the number in the bracket. So this goes to 1/3. And then we've got integrating that normally goes to sine x, but the number's fine because it's just x in the bracket. Okay, like I say, I'll get worksheets and things. So there's shitload of practice for it. We've got a couple of things going on there. 3x cos half x and plus 2 over x. So yeah, there's a couple of things involved here. There's the e to the x, but there's also the 2 over x bit. Now, whenever it's over x only, so I know I did a over x square root of x just before, but when it's over x only, it goes to ln x. So you remember, if we differentiate ln x, it goes to 1 over x. Vice versa, it goes the other way. So the integral of this one, e to the 3x, we're going to keep e to the 3x. The power doesn't change, but we do divide by the number. Okay, so it's these same rules, but just the other way around. I appreciate it might be difficult nestling all this together, but anything I've said in the differentiation skills, there's an opposite version here, and you just might need to watch it 2 or 3 times. So divide by that number 3, integrate cos as normal, so that's going to go to sine a half x, but then chain rule, divide by the number in there. So divide by a half just is the same as times by 2. And then finally, this is like 2 times 1 over x. Okay, so we've determined 1 over x goes to ln x, and when you differentiate, it goes to 1 over. So just another rule to remember. So there's effectively there's e to the x, there's ln x, and there's the trig. All have different ways of differentiating, and you just need to understand and get comfortable with those, and memorize them, I suppose. Right, last one, I'm calling it a day. Yeah, very similar actually. So e to the 0.5 x, so plus or minus, plus 1 over 4x minus 7. Okay, so same deal. So the 0.5 x stays the same. It does not change, but we do divide by that 0.5. So we get 2. And then this is effectively 1/4 times 1 over x. Here you can separate that out. So we get 1/4 ln x. And then the final one is just minus 7x, and then plus c. Good, right. The integral of this how we represent it is, 6 and 2 like that, and you integrate in this. What you're doing here to find the area is you're going to integrate, you're going to put x equals 6 in and get an answer for when it's 6. You're going to put x equals 2 in and get an answer for 2. And then whatever these answers are, answer for 6 and answer for 2, you just subtract and you get your area. Okay. Same deal on these. Same deal. So, it's just written a different way, but put the 6 and the 2. So here you integrate and you put a 2 and a 1 in and you subtract those two answers. Here you integrate and you put these two radians in and subtract the answers. And yeah, that's fine. Okay, cool. Thanks, guys. And sorry for any Leeds fans last night. Goalkeeper had a nightmare, so we're still top of the league. Bye.